Station.
Go.
Com.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ACS.
Go.
Redline monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
ACs go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. Timer T0 is planned for 15:36:00 Zulu. Set the count to start at 15:32:00 Zulu.
Roger. T0 is set for...
Polling is complete and the team has been given the go for launch. The countdown will resume in approximately 2 minutes. From T-minus 4 minutes until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team confirm securing of Atlas LO2 topping, followed by the call to transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures. A final status check of Atlas, Centaur, and GPSIIF readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engine ignites and performs a health check, followed by ignition, to lift the vehicle off the pad. After liftoff, you'll hear the voice of Marty Malinowski, providing launch vehicle ascent data.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
3:55.
Ground power is enabled.
The countdown clock has resumed, and we're now proceeding towards an 11:36 a.m. Eastern Time liftoff.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
250.
Yes, internal.
T-minus 2 minutes, 27 seconds and counting. Once the rocket lifts off, it'll take only about 78 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
Launch sequencer start.
151.
Securing Centaur LH2.
Securing Centaur LO2.
Launch enabled.
FCS armed.
T-minus 1 minute 30 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
Orcas armed.
FCS count started.
110.
Valves locked.
60.
T-minus 1 minute and counting.
Range green.
40.
Stable at step 3.
T-minus 30 seconds and counting.
25.
Status check. Go Atlas.
Go Centaur.
Go GPS.
20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 10th GPSIIF satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users.
Body rates look good.
You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
RD-180s continue to perform well. Injector pressures are in band. PU is controlling nominally. Minor attitude rates at this point. HER roll program has completed. Vehicle body rates are controlling right down the middle. Approaching supersonic speed. Body rates continue to look good. Mach 1. RD-180 performance continues to look very good at this point. Injector pressures, pump speeds, all within band. Max Q. Body rates continue to look good. Booster has throttled back, right on schedule. Engine response looks good. Current altitude is 10 miles. Downrange distance is 4.5 miles. Current velocity is 1,840 miles per hour. Booster engine performance continues to look very good at this point. Body rates controlling down the middle. Plus and battery voltages are stable. Tank pressures look good. Coming up on closed loop steering. And we have begun Q alpha limited steering. Vehicle response looks good. Engines continue to perform nominally. And we have fired the fire isolation valve. That system is now pressurizing the RCS to flight pressures. Response looks good. Booster engine continues to perform well. Pump speeds and injector pressures are in band. And we've completed the Q alpha limited steering. Body rates continue to control well down the middle. Booster has throttled back. Engine performance looks good in response to the throttle command. currently accelerating at 4.7 Gs. Coming up on our 5G throttle segment. And booster has begun to throttle to maintain a 5G acceleration level. Boost phase cool down is underway. And we've now begun to throttle to maintain 4.6 Gs. Boost phase chill down is complete. Coming up on BECO, and we have BECO. Engine shutdown looks good. We have retros and stage separation. Looks like a clean sep. We have LOX and fuel pre-start on the RL10. The GN2 purge for into the RCS is underway. We have ignition and full thrust on the RL10. We have indication of payload fairing jettison. Looks like a clean sep. Centaur steering has been enabled. Small body rates correcting out attitude errors. LOX tank pressures have vented down as expected. Storage bottle pressures look good. Bus and battery voltages are stable.
This is Atlas Mission Control at T plus 5 minutes 5 seconds into the flight. We've just heard Marty Malinowski report the successful execution of events comprising the early part of today's mission, and all systems continue to operate nominally. The mission is currently in the first of 2 Centaur engine burns. Our next event, the Centaur main engine cutoff, will occur in approximately 12 minutes. I'm now joined by Lieutenant Elaine Sudakun from the United States Air Force GPS Directorate. Lieutenant, thanks for joining me.
Steve, thanks. It's an honor to be here and represent the United States Air Force.
What is this current status of the GPSIIF satellites?
We currently have 9 of 12 Boeing GPSIIF satellites in orbit. You've just seen the Boeing GPSIIF10 launch and join the rest of the constellation. 11 is in processing here at Cape Canaveral for an October 30th launch date, and 12 is back home in the Boeing facility in El Segundo awaiting a February 2016 launch.
The GPSIIF series brings the legacy signals L1 and L2 and a new L5 signal into play for position, navigation, and timing users. What are these signals used for?
All these signals are part of the Boeing GPSIIF navigation payload and provide information including the GPS date and time, satellite health, satellite ephemeris, and almanac information. The L1 frequency carries the L1 CA code for civil users and the L1 PY and L1 M code for military users. The L2 frequency carries the first modernized civil signal, L2C, and the L2 PY code and L2 M code for military users. Finally, the L5 frequency carries the newest modernized civil signal, which is the safety of life signal used for Federal Aviation Administration requirements.
Many people think of GPS as the navigation system in their car or their maps application for their cell phone. Can you provide some other uses of GPS?
Well, currently I'm stationed in California, and one of our big concerns is water usage. The agriculture community relies on GPS signals for precise positioning to optimize use of seeds, fertilizer, and of course water. Additional uses include monitoring sea level changes, engineering surveys, and scientific applications like weather forecasting. GPS is also vital to first responders in emergencies, ambulance, police, fire, search and rescue, and also OnStar. Billions of devices and systems across the globe depend on the reliable and available GPS signals provided at no cost to the users.
Would you explain how GPS is used in credit card and ATM transactions?
Well, Steve, I'm a CPA from the University of Illinois, Go Big Ten, and I know a little bit of financial transactions. Companies worldwide use GPS to timestamp business transactions and provide a consistent and accurate way to maintain records and ensure their traceability. Major investment banks use GPS to synchronize their network computers located around the world, and large and small businesses are turning to automated systems that can track, update, and manage multiple transactions made by a global network of customers.
There are currently 31 satellites in the GPS constellation, from GPS Block 2 to GPS Block 2F. What improvements have been made in today's generation of GPS satellites, and what new services have been provided?
Each new generation of satellites includes improved services for all users around the world. Accuracy improvements have been made primarily through advancements in atomic clock technology and improved ground monitoring. Space vehicle design life has increased from 7.5 years with the GPS-2A to 12 years with the Boeing GPS-2F. The Air Force has increased the number of navigational signals available to users, and the next generation GPS-3 satellites will provide a fourth civil signal, L1C, that's going to be the first internationally interoperable signal. GPS-3 also provides even more signal power and greater resistance to jamming and spoofing. To take advantage of these satellite capabilities, the Air Force's Military GPS User Equipment Program, along with its industry partners, L3, Rockwell, Collins, and Raytheon, are currently integrating and testing the first M-code-capable GPS receivers. These receivers bring advanced cryptography, anti-jam, and coverage for military users around the world.
Lieutenant, what makes GPS more desirable than other nations' GPS systems?
The proven, reliable, and unparalleled performance of GPS over the last 20 years has made GPS the gold standard of position, navigation, and timing. GPS makes a clear promise to its users in its standard positioning service performance standard, including accuracy, availability, and reliability. Over 1 billion users on a daily basis use GPS for all of their position, navigation, and timing needs.
Lieutenant, GPS really is an amazing system with an amazing capability. Let's take another look at a short video highlighting more about GPS.
The Global Positioning System is a marvel of the modern age. It consists of more than 30 GPS satellites circling the globe over 12,000 miles above us. In tightly controlled orbits, these U.S. Air Force satellites continuously transmit their signals to Earth. An extraordinary technology, GPS enables anyone with a GPS receiver to determine their precise location and the exact time anywhere in the world, usually within a meter and within a billionth of a second.
GPS is ubiquitous. It's everywhere. It's in our cars, it's in devices that you use to determine how far you've run or ridden your bicycle.
With billions of users and countless devices, it is easy to take GPS for granted. But it is the essential platform for innovations which enables us to do everyday things like buying gas at the pump and getting directions. And amazing things like tracking ice melts and saving lives in ways that were formerly impossible.
The beauty of the GPS system is that it's available for everyone. The cost of entry for any user is simply the cost of their receiver.
Boeing helped make GPS possible. It's been the U.S. Air Force's prime contractor on 4 major programs, replacing the initial group of satellites as their service lives were completed. Overall, Boeing has produced 2/3 of all GPS satellites, more than 40 in all.
Satellites are normally built in a low volume, perhaps 2 or 3 at most, and they're usually sit in one spot and resources are brought to the satellite.
Now, to ensure that GPS is available whenever it's needed, Boeing has changed how satellites are made. It's producing 12 new GPS satellites using a streamlined process based on its efficient and advanced airplane assembly line techniques.
Our goal is to have the highest quality.
These new satellites bring next-generation performance to the GPS constellation we all use every day. As a result, they are delivering new levels of accuracy to what is already a remarkably accurate system, and they are being built in a much more efficient way, ensuring that this essential technology is available when we need it.
Line temperatures are good. Tank pressures are stable. Storage bottles look good. Centaur is currently flying at an altitude of 229 miles, downrange distance 2,129, current velocity 15,980
This
miles.
is Atlas Mission Control at T plus 12 minutes, 13 minutes, 1 second of the flight, and all systems continue to operate as expected. The Atlas Centaur second stage and GPS satellite are currently located over the North Atlantic Ocean, southeast of Greenland. Our next event, the first Centaur main engine cutoff, or MECO 1, is scheduled to take place about 4 minutes from now. Here's Marty Malinowski.
And Centaur has IIP vanish. At this point is now orbital. Current altitude 206 miles. Downrange distance 2,591 miles. Velocity 17,576 miles per hour. RL-10 continues to operate well. Chamber pressures, box pump discharge, and fuel venturi all look good. Two minutes to MECO. Tank pressures continue to remain stable. Storage bottle pressures look good. Body rates are controlling right down the middle. And continuing to see our thermal conditioning firings at the expected intervals. One minute to MECO. Centaur engines continue to look good. Tank pressures and storage bottles are stable as well. PU is controlling near nominal. And Centaur PU has been commanded to fixed angles. Preparation for MECO. And we have shutdown. Engine shutdown looks good. We have 4S settling motors on.
This is Atlas Mission Control at T-plus 17 minutes, 27 seconds into the flight. Marty Malinowski just confirmed MECO 1, or cutoff of the Centaur RL-10C engine. The mission has now entered an extended coast phase, which will last about 3 hours. Following MECO 1, the mission trajectory changes to a southeasterly heading, flying over Eastern Europe, Turkey, and Saudi Arabia. It will continue in a south-southeasterly direction over the Indian Ocean. Following a short second burn of the RL-10C engine, Centaur will deliver the GPSIIF10 satellite to semi-synchronous orbit over the southern Indian Ocean south of Australia. Separation will take place about 3 hours 23 minutes after liftoff. Due to the long duration of today's mission, we'll conclude our live coverage in a few minutes. But before we sign off, Lieutenant Sorikun, we have an important anniversary to recognize.
Yes, Steve, we do. After the GPS constellation achieved initial operating capability in 1993, the Air Force deployed 24 satellites in 6 orbital planes around the Earth. In 1995, after completing all system tests, the Air Force declared full operational capability on July 17, 1995. The Air Force officially published an announcement on this momentous achievement, signifying the culmination of 20 years of research, development, and implementation that led to this revolutionary navigation system. Over the last 20 years, GPS has become an integral part of technology that affects the lives of billions of people around the globe.
Congratulations to the Air Force on achieving a truly life-changing milestone. That's quite an achievement. We now have a very special video on the anniversary of GPS achieving full operational capability.
Let's take a look.
Okay.
Greetings from the International Space Station. I'm astronaut Scott Kelly. On the 20th anniversary of the full operational capability of GPS, I'd like to recognize the importance of this system in our lives and congratulate the developers, operators, managers, and technicians who made it possible. Originally developed as a military tool, GPS's precise navigating and timing is now part of everyday life on and off our planet. Whether I'm living on the International Space Station, landing the space shuttle, or just driving my car, GPS is critical to making sure I do it safely and accurately. Thank you.
Thank you, Astronaut Kelly. Lieutenant, congratulations again on the 20th anniversary of GPS, and thanks again for joining me today.
My pleasure. It's been an honor to represent the United States Air Force and the GPS Directorate on today's successful launch.
I'd also like to thank Marty Malinowski for his support of today's show. For more information about the Atlas V, please visit our website, ulalaunch.com, or join the conversation on Twitter or Facebook. We'll complete our live coverage with another look at today's liftoff, which occurred on time at 11:36 a.m. Eastern Time. I'm Steve Agate. On behalf of the entire ULA launch team, thanks for joining us, and have a good day. This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 10th GPSIIF satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users.